Okay, I'll introduce you now. So thanks for coming back, everyone. Our next talk is by Ben, all the way from Washington University. And Ben will be speaking to us about mastery-based assessment in a proof-based maths course. So Ben, over to you.
Thank you. Thanks for the introduction and the opportunity to speak. It's a little disconcerting. I can't see you guys, but please interrupt me via that microphone if you have a question or want to clarify something. As the intro said, the title of this paper says it all, and this is an article which is going to appear in the IJ Mest special edition associated with this conference. I'm very glad that worked out. I was allowed to work with this kind of long list of authors. If there are any US people in the room, Nelson Carter and I met through Project Next over the last year and have been working on this paper together. One of the great joys of this project was actually these four authors who are all graduate students in pure maths, mostly algebraic geometry. And it's been really, really great, honestly, seeing them expand their imagination for what research that's beneficial to the mathematical community can look like. So this title actually comes from a statement that Rachel, the last author, said. She said that she was intrigued to explore formative assessment in a class that was transformative for her. And so that's where the kind of this title comes from. I'm sure many of you have operated with formative assessment models of some form or another, but let me just kind of set things up, maybe how I think about them a little bit. Assessment, right, is a part of the learning process. It's a part of the formative process for students. It's a meaningful opportunity for feedback and for reflection. Students to receive feedback from teaching teams and to reflect on their own work. An opportunity to make and learn from mistakes, or also known as learning. But there are some pitfalls that especially some of the traditional, most widespread assessment mechanisms suffer from. There's sort of an interpretive issue. What does me giving you 8 out of 10 on a question really mean, especially if clear rubrics are not provided? There's a big difference, right, between scoring 80% on 100% of the assessment versus scoring 100% on 80% of the assessment, just as one instance. But there isn't sort of a meta meaning or a universal meaning to many of the sort of numerical point scores that we allocate. And of course, maybe the bigger issue is sort of an implementation execution issue. How can we learn, and how can we learn from mistakes, or even feel normalized to make mistakes if most of our assessment is once and done, where there's no opportunity to revise or no opportunity to take similar assessment? And of course, there are many, I'm sure many people in this room have combated these things and the many other issues with traditional summative assessment. But I want to talk about one such approach, which is mastery-based assessment. You might know it as standards-based, grading for growth, lots of names that this goes under. Right, and this tracks all the way back to the work of Benjamin Bloom and Keller in the 60s. Many people, I've just sampled some references at the top, but many people have written this is not a sort of new idea, but is still not. I would say it's maybe one of the more widespread, at least in the US context, one of the more widespread alternative assessment models, but certainly is not the norm, or in many contexts mainstream. These are maybe some principles that I distill from this work, and again, lots of different ways of looking at this. But these principles, mastery is repeated demonstration of understanding. You might want to think about that as a demonstration of competency. Like I didn't get lucky. We didn't fluke this question. I'm able to repeatedly demonstrate that I have mastered a skill or achieved a skill to a certain level of competency. It's binary. So this is one of the solutions that mastery offers to the 80% issue. Mastery is yes, no. Either I've mastered a skill, I'm able to repeatedly demonstrate my understanding, or I haven't. And that feedback is clarified. And it's high grace. Mastery is achieved by allowing opportunities to make, amend, and learn from mistakes. So intrinsically, that means there are multiple opportunities to execute a certain skill. So often this is implemented by defining key skills or key objectives for a class. Key things that maybe you hope a student comes away with, and maybe this skills versus objectives tension is maybe a little bit helpful. And there are ample opportunities to demonstrate mastery in those directions, in those skills or objectives. And ample here really meaning making a mistake once, twice, right? However many times isn't necessarily going to impact your ability to achieve well in the class. An earlier version of this talk I wrote in a coffee shop called Bloom in Sacramento, California, where my in-laws live. Which of course feels very fitting. And if you're a coffee person like me, maybe the bloom is the sort of one of the most formative parts or interesting formative parts of the coffee making process. Okay, so let me tell you a little bit about the context for this study. So WashU, I'll talk a little bit about WashU in a minute. The course was a course that I expect many of your institutions have a version of. We call it Foundations for Higher Mathematics. It's a skills-based kind of transitional course to upper-level math. It's the transition course from our sort of lower division, early years computational-driven courses to upper-level courses, which are more proof-reliant. So it almost has no content. But we sort of no canonical content except the expectation or hope that students come out carrying some of those skills of proof making and proof writing, mathematical communication, and sort of the fluency of practice of proof. I'm also going to emphasize here some of the distinctives of our study, or some of the things that motivated us to do this. Again, at least in the US context, a lot of places where mastery has been studied are in these lower division calculation-oriented courses. The kind of classic calculus sequence, pre-calculus, differential equations, a lot of these courses which are not proof-driven for most of the US. These are a lot of the courses that have been studied. As described, this course is a skills-based course, and mastery is a kind of a skills emphasizing methodology. And so we had some hope that it could be amenable to this. We couldn't find a ton of literature on this. WashU, Washington University in St. Louis, it's a private R1 institution in the US. We're in the Midwest, we're in St. Louis, Missouri, not St. Louis. R1 is just our classification for being a research-focused institution. We have about 10,000 undergrads and about 10,000 grad students, which is an absolutely wild ratio. And again, this is in contrast to many sites in the US where much of the literature and mastery-based assessment kind of currently resides. It's a lot of liberal arts colleges, so teaching-focused institutions that often don't have a PhD program, or in large state schools. We're sort of in an interesting in-between. And so again, this is the context in which I work and operate. And so I'm interested, but it's also a climate which lives between some of the big R1 universities and some of the smaller liberal arts colleges, where there's more flexibility to try alternative assessment. And the last thing, which again, I expect is maybe a kind of tension that many of you live in. I'm sad actually to not be there in person and not hear more about the academic context across Australia. But most courses at my institution do not teach heavily using formative assessment, especially in STEM. They use traditional summative assessment, homework, quizzes, exams. And so it's a lot to ask students to walk into a class that heavily relies on alternative assessment. And expect them to just carry on as if they would in another class, right? There's a learning curve, there's novelty, and also my teaching team, graders, TAs, other faculty are not necessarily. I can't assume that they are acquainted with some of these methods. And so there's been a draw in a number of institutions to come up with sort of hybrid assessment models. Hopefully, we're far enough from COVID that I can say hybrid and mean what I mean. Where we are drawing on both those traditional expected elements of assessment and some of these more formative alternative forms of assessment, which have been shown to have great impact on students. So part of this was also to explore how in this kind of hybrid context, using traditional and more innovative strategies, how the same formative benefits that have been documented elsewhere for mastery-based assessment can persist in a hybrid setting, which is maybe more familiar for both the educators and students. So 2023, I taught 2 sections of Math 310 of this Foundations for Higher Mathematics Introduction to Proof class. One heavily using mastery-based assessment, and one with just a more traditional assessment model, the usual way that class is taught with homeworks, quizzes, and exams. Our metrics, comparison metrics, they had 2 common exams. So they had a common midterm and a common final exam. Midterm is we have sort of 14, 15-week semesters. I think the midterm was in week 8 and the final was in week 15. And we use these as metrics for performance. But we're also interested in the student experience. Students were also submitting monthly reflections on the course, including some which were directed specifically about how mastery was impacting their experience. Cool. So let me tell you a little bit about how we implemented it in this context. So there were 19 learning objectives. If you've done mastery, you might think that's a large number, and you would be right. And that's been one of the main tweaks we've made moving forward. But these objectives were things of the form I've given you 2 here. There were a bunch of 18 of them were these numbered objectives, 1A through I think 7C. A kind of an exemplar is this 4A. I can use the skill proof by induction. Right? Meaning I can write a coherent proof by induction, which appropriately is chosen, the method is chosen appropriately, and it proves the statement that I'm claiming to prove. There was also stuff in here like using first order logic effectively, certain components of first order logic, step theory, testing for countability, stuff like that. Then there was also this kind of one outlier objective, x.a, which was I can write a clear and rigorous proof. And this was sort of an overriding objective. It's a little bit different to all the others. This was sort of testing student or trying to assess student communication. So there was no clear it's kind of implicit maybe in this clear and rigorous that the proof is correct, but you could get this x.a without having a correct proof. This is more an assessment of your mathematical writing and communication. So then the bit that, again, anybody who implements mastery dreads doing, which is communicating how the grade is calculated. Students aimed to get 2 checks for each of these objectives, for each of those numbered objectives. So in other words, they needed to do 2 proofs by induction on certain pieces of assessment, which we'll discuss. And throughout everything, also get 10 writing checks, meaning write 10 good, clear, rigorous proofs. The media in which they could demonstrate this, these weekly in-class quizzes, about 20, 25 minutes, bi-weekly homeworks, these praxis assignments, which I'll talk a little bit about at the end, but these are sort of mixed media. One of these was record a video solution or write a lesson plan or a workshop plan around that objective, collaborate and give feedback. And the kind of last resort was they could come to office hours and do a brief oral exam. And I'll note, as I pitched at the beginning with these sort of multiple opportunities, it worked out at about 4 opportunities for each objective. So if you're trying to get it, if you're trying to get each objective twice, you sort of have 2 times to learn to make and then learn from a mistake. I'll also observe one of the other dynamics that was going on here was we realized, or we thought that homework would be the easiest mechanism of generating checks. So there was a participation component, but after that, you could only get a limited number of checks from your homework. Really, the quizzes were supposed to be the main pipeline for demonstrating mastery. Yeah. Okay, I'll just leave that up for a second. Feel free to digest that without me talking. Again, this is the bit I always dread in class, but I hope that's clear. Feel free to interrupt me if not. Cool. Oh yeah, and then the grade at the end, like I say, it's kind of this is this hybrid model in effect. 50% of the grade was mastery. It was calculated by a threshold system. Like if you were a certain number of checks below a threshold, your score would be modified. And 50% of it was from participation and then just straight exam score, as is done in traditional summative assessment. Okay, so let's talk about the findings, right? So we had these two sections, one which is as described here, this 50-50 mastery and then kind of exams. The other just using traditional assessment media. The findings were, well, on the sort of performance exam side, there was no significant difference in the distribution of exam scores between the two sections. The midterm was unfortunately really easy and didn't give much useful information. Every p-value I computed was 1. Just to give you a sense then of the final, so that exam right at the end, it was a cumulative final covering the whole course. Mean final scores 33.4 out of 40, 34.2, so slightly higher on the traditional assessment side. Standard deviations pretty similar, 3.7, 4.5. Various tests. I'll show you a plot in a minute, but various tests on the data, really for distribution, right? Because maybe that's what we're more interested in than either of these kind of numerical statistics. Various tests, chi-squared tests, KS tests, t-tests, all gave very high p-values, between 30 and 80. 30 was the lowest. Most of them were around 60 to 80. And so really we were not detecting any meaningful difference in the distribution of scores between these two sections. Here's a particular binning. This is from one of the chi-square tests. And you see the distribution is fairly similar. Maybe some of the sort of more jarring differences is right here in the center, which is where there's a big cluster of scores between 34 and 36, and how they fall between these is sort of the main driver here. Okay, but I'll let you look at that for a second. Great, and in this, right, the light blue is the traditional assessment. The green is the mastery based. Okay, maybe the more interesting part was the coding, this inductive coding we did of the reflection data. So there were 3 reflections in particular out of 7 that applied specifically to mastery. And so we coded these. If you're into coding, it was sort of an initial and process coding process. 15 out of the 31 mastery students reflected positively, having multiple chances to demonstrate understanding. They found this to be something that contributed to their learning. 8 out of 31 reported reduced anxiety. I'm sad I'm not there. I would love to talk to Mark and others interested in math anxiety about how alternative assessment mechanisms can contribute to that. A different 8 out of 31, or not the same 8 out of 31 students, felt mastery was helping them learn more effectively. And some of the sort of negative reflections or negative coded reflections, 9 of the students reported some increased stress due to regular weekly assessment, right? Weekly Friday quizzes. 5 out of 31 students felt what was expected of them was unclear, but all of these 5 were in the first reflection. And this is a typical phenomenon when adopting these alternative assessments, right? There's a novelty cost. We were shocked and delighted to find that this was not reported. This was not a theme that came up in any of the later reflections. So let me kind of wrap things up with some of our reflections or some of our musings on this. As I'm sure nobody's surprised, mastery seems promising for this type of class, this sort of skill-driven class. In this sense, the exam findings are positive, right? Despite the novelty costs of this being an unorthodox or unfamiliar way of operating in the classroom, student exam performance seemed unaffected. That's not clear. It would be nice to see a boost of that. But again, maybe we'll hit a little bit more about why else we might not be seeing that. Students in general reflected very positively. And again, some of those negative features were mostly transient. They faded away after the first reflection, but they felt many of these experiential features of mastery that you would hope students to report. And this is and this sort of limitations is, all of these things, anything formative, right? There's a strong time component to it. And when this is the only mastery-based class that you're taking in your degree, or one of the few, it's very hard to kind of really access those benefits. We've actually been talking a lot with our physical therapy school here, where they are trying to do something very similar. They're kind of studying what they would call rustiness, like how skills atrophy in their students once they're covered. And I think us doing something similar is wonderful. We have some early stage plans for a longer term study, sort of addressing what math rustiness looks like and how mastery and other alternative assessment can contribute to this. Another big drive in our context right now is project-based learning, PBL. And thinking about similarly, you give me this nuanced project with evaluative content, with kind of really interesting higher level Bloom stuff going on, and then we assign it a numerical grade. And so we've been trying to integrate mastery ideas with project-based learning. Of course, project-based learning is at an interesting time with the rise of generative AI. I'm just finishing right now an optimization course, like a convex optimization course, which is project based. And one of the big questions that we hope to ask students and get some information on is how the mastery system incentivize or disincentivise them using generative AI in their project work, which is now especially vulnerable to this. And I mean, it was the experience again. If you've taught a mastery based class, and I'm sure you've maybe had this experience, is that graders can get burned out by the kind of by both the quick turnaround and the higher amount of grading as students are retesting, or even just the complexity of how to input that in an LMS that's really maybe not designed for it. We use Canvas, which does not do great with mastery. And so we're still trying to explore how to keep many of these formative benefits in a leaner way, in particular a way which is less taxing for graders who haven't received training, and how to provide PD and training for those graders so that they can be partners, and TAs so that they can be partners in that process rather than just sort of accessories to it. So yeah, like I say, in differential equations and this convex optimization course, we're trying to implement this now. Maybe in my last minute or so, I'll just tell you very briefly about these praxis prompts. Again, we've been trying to think about UDL, Universal Design for Learning, kind of choose your own adventure for students. And mastery, again, is a really interesting canvas for this, it seems. So in this context, there were these three unitalicized modes that students could also earn checks: recording a video solution, collaborating with a peer, composing a lesson plan. In later courses, we've started to add this sort of explain your thought process for a problem, or summarizing, kind of synthesizing information over longer periods of time, summarize the story of the class. And so again, mastery in a way where multiple opportunities and mistake making is incentivized. It's just really interesting. We're finding it really interesting to think about what student access is opened up by alternative assessment, specifically by mastery. So thanks so much for your attention. Sorry, we're a minute or so over. Happy to talk more. Again, I'm sorry to not be there in person, but I also look forward to dialoguing right now if you've got any questions. So thank you.
Thanks. Thanks, Ben. I'll just throw this open to anyone with a question. Okay, I'll just come. You can hear us, right, Ben?
Yep.
Great. Okay, I'll just pass the mic over.
Hi, Ben. Thanks for that. That was really cool. I have a wonder that your exam scores didn't get any better. They also didn't get any worse. I'm wondering if students are kind of taking advantage of the 4 opportunities and are kind of min-maxing the efforts. And do you get students that try hard and get the first 2 ticks and then don't bother attempting the second 2 because they've already got them? And then they're doing the same thing as the other students where they kind of cram for the exam and then just forget about it until they need it again? That it's kind of, they're just working their way around this structure you're trying to put in to help them actually get that mastery, and they're just doing the same thing as the old way?
Yeah, it's a really interesting question. So one of the features is actually they are very much incentivized to get the checks early and then not pursue those questions again. The idea being that if you've hit that threshold for repeated demonstration, which in this class was 2 checks, right, like 2 good proofs, you don't need to do it again. You've kind of convinced us enough. You've also had some participation on homework where you've had to do that, and then these exams. So actually, all of the quizzes have too many questions. So they had 20 or 25 minutes. Writing a proof, I mean, you're lucky if you can get 2 or 3 proofs out in that time. There were usually 5 or 6 questions on a quiz, and students were expressly told you should not expect to finish this quiz, meaning that you hit objective 1A, which I think was like a set theory thing, was we were really hoping that you would knock that out in the first 3 weeks, and then the remaining 2 times that it appears on quizzes, you shouldn't do those. You should now be focusing your time on these later objectives, which are now appearing for the first time. So some of it is, so it is an interesting, there is a kind of gamification, but it's almost like we encourage that gamification. We gave them like a little, like almost like a scratch sheet where they could choose which objectives they were going to focus on. The other interesting thing to the second part of what you said was, I don't know why it's not in these slides, but again, around 8 or 9 students reported that mastery increased or benefited their study habits. That was the specific thing they named. Again, this wasn't a prompt that we brought to them. This was a concept that they were bringing up, in that it made them think strategically about what am I going to prep for this week. And the regular testing, then many of them reported that that it helped them with their exam. It decreased cramming a little bit, because they were having to prep and having to think strategically, like, oh, actually, I'm going to need to do this objective next week. I should prep for it. So they had notes. So there were some benefits that they were seeing there, of course, right? Of course, especially when some of these are, you tested something in week 1 or week 1 and 2 and you knocked it out, and then there's an exam 5 weeks later. I bet those people were cramming. So yeah, we'd like to understand better the relationship between sort of this, but it does seem that it at least made students think strategically about their study habits and about their study plans, which I think is a good thing.
Thanks, Ben. Interesting talk. I have also a question about the exam. I think it's related to the previous one, which is the qualitative difference, whether there's a qualitative difference in the way the students were responding to the questions. Like imagining that, say, a student going through the mastery-based approach, validating, let's say, the first 4 learning objectives, would be more confident answering the questions in the exam related to those objectives?
I wish we had fine-tuned information like that, because that would be wonderful. It would be wonderful to see that. I can't give a robust answer to that. But again, the other place my mind goes on this would be exactly the other thing that mastery has enabled, regardless if it's their demonstration of mastery. They've also, even if they haven't knocked it out quickly, they've had the opportunity of getting multiple rounds of feedback. Like the student that I would be interested in light of your question would be the student who, without mastery or whatever, would have gone into an exam with, I didn't do this well on homework, or I didn't do well on this 1 or 2 opportunities I got for this. Whereas the mastery-based student, the student I think of in this instance, would be one of the 4 kind of times that objective appeared. They failed it the first 2. That means they got 2 rounds of feedback that a student otherwise might not get. Then they hit it twice, let's say once or twice, and then they hit it on an exam. And at this point, that student has had sort of 4 rounds of feedback, two sort of mostly critical, 2 mostly affirming, and then heads into an exam. That's the sort of student that I would love to kind of track there. Like in principle, that student should be set up in a better place. Getting data on that would be awesome.
Fantastic, Ben. And thank you once again for a really interesting talk. I'm afraid that's all the time we've got.
No problem.
Yes, our next presenter is waiting to give their presentation. So once again, thank you very much, Ben.
My pleasure.